right, everyone, so we're finally going to be writing proofs, and this video may be a little bit longer, so it may have to be extended into 2 videos. But let's get started. We're going to learn some more things that we can say as justifications in our proofs. Now, we haven't learned any theorems yet, so we're not going to be using theorems in our proofs. But there are some things that we learned technically last year. Now, you didn't necessarily know that these were actual properties, but when we solved equations, we used the following properties to do so last year. We used the addition property of equality when we had something like this. And the addition property of equality was when we maybe added 3 to both sides. So if you add a number to both sides of an equation, that's the addition property of equality. Now we're just going to call it the addition property. We don't need to call it the addition property of equality, but the addition property, the subtraction property, the multiplication property, division property, substitution, distributive, cross products property, and simplifying. These are only used when we are dealing with equations or equal signs. So let's look at the subtraction property of equality. That would be something if we had this, and we were asked to solve this equation. What we would first do is we would subtract 3 from both sides. And doing so, we use the subtraction property of equality. Multiplication property of equality is if we were to have something like this, where we would need to multiply both sides of this equation by 4 to solve for x. We used multiplication, so that's a multiplication property of equality. And then the division property of equality would be something like this. If I had this equation and I asked you to solve for x, what you would do is you would divide by 4 on both sides. Now, these may be used in some geometric proofs, but it's not going to be super common to use them in geometric proofs. We will actually use them at some point in our geometric proofs this year. Now, the one that is really common that you will use quite a bit in geometric proofs is the substitution property of equality. And again, we can only use this property when we're dealing with an equation. So if you see congruent symbols, you cannot use the substitution property. So this would be something like if I had the expression, the algebraic expression, 3x plus 2, and I told you that x is equal to 4, what you could do with this information is you could take that 4 and you can substitute it in for x in my algebraic expression to get a 3 times a 4 plus a 2. What we just did is we used the substitution property of equality. And we're going to write a little note below this that we cannot use this property when you have a congruent symbol. There's something else that we use instead. So substitution can only be used when we're dealing with equal signs or equations. The distributive property, it's not one that we're going to use a lot when we're dealing with geometric proofs, but we may see something like that. The distributive property, remember, is when you have a number outside of parentheses, and what you need to do is you need to distribute that number into parentheses to make a 3x plus a 6. What we just did there was we used the distributive property. The cross products property of equality is something you may not remember, but we did use this quite a bit when we solved proportions. So if proportion, remember, is a fraction set equal to a fraction. So if I had something like this. And the cross products property is when I take the numerator of my first fraction, multiply it by the denominator of my second, and then set it equal to the product of the denominator of my first fraction times the numerator of my second. That is the cross products property of equality. We're just going to call it the cross products property. And then lastly, the last algebraic property, because these are all properties of equality, so it's when we're dealing with equations only. The last algebraic property is simplifying. So if I had a 3x plus a 2x in an equation, and let's just throw in a plus 9 as well, I could combine my like terms together, and that gives me a 5x plus a 9, and that is called simplifying. That's an algebraic property. So these are all properties of equality. Again, they can only be used when you're dealing with equal signs. Now, the following three properties can be used when you have equal signs, but they can also be used when you have congruent symbols. The reflexive property of equality or congruence is pretty self-explanatory. It says that something is equal to itself. So if I had A, that would be equal to A because it's the same variable. With congruent symbols, we may see something like this. Segment AB is congruent to segment AB. That's called the reflexive property when we are able to use or identify that something's equivalent to itself. And this will be used when we start to do triangle proofs, which actually is not in this standard, but we will use the reflexive property quite a bit. Now the symmetric property, we're not going to use that often. In fact, it's not one that I'm super concerned about you knowing. However, the symmetric property basically states that if I have A is equal to B, that also means that B is equal to A. Or if I had, let's say, a congruent symbol, if I had AB is congruent to CD, that also means that segment CD is congruent to segment AB. So basically, it's just a mirror of each other. A transitive property, this is going to be one that we use quite a bit, and also it's going to be one that you may have some issues with. So please make sure that you understand this one. Basically, the transitive property states that if I have A equal to B and A equal to C, since A is equal to both B and C, then I can conclude that B is equal to C. That's the transitive property of equality. Now, if I were to do the transitive property of congruency, we would have something like this. AB is congruent to segment CD, but also segment AB is congruent to segment EF. So with this information, I can conclude that segment CD is congruent to segment EF. Now, some of you may be thinking this is similar to the substitution, because for example, in the first example, A is equal to B and A is equal to C. What I can do is I could take B and I can substitute it in for A in my second statement to get B is equal to C. Now, when we are dealing with something like this, you can either use substitution or the transitive property, because these all have equal signs. But if we are dealing with something like this with congruent symbols, remember, we cannot use substitution when we're dealing with congruent symbols. So we cannot say that the reason for this is substitution. We would need to say that it's the transitive property of congruency. All right, so these are all things that we are going to be using today in our lesson. Now, the first step in your proof, we're going to start to write two-column proofs in a moment. The first step is always going to be what is given to you. So when you write down your first step of your proof, your justification or reason that you would write in correspondence to it is that it was given. All right, so two-column proofs, these are proofs in which the steps are written on the left. So we're going to write each step and number each step on the left. And then we're going to number each reason or justification that corresponds with the steps on the left. The reasons and justifications are going to be written on the right of your proof. And we're going to see some examples of that in our next video. So we're going to continue this in our next video. We're going to start with some algebraic proofs because they're a little bit easier than geometric proofs because you guys already know the content of algebra, so it's easier to write an algebraic proof. Now, when we start to do geometric proofs, you're going to be learning how to do a proof alongside learning the content of geometry. So the reason why geometric proofs are so much more difficult than algebraic proofs is because you're basically learning two things at one time. So please be patient with yourself. It's not going to come easy right away, but remember, we can think of proofs as a puzzle. We can also think of proofs as helping us in terms of our career. And if we think of those two things, we can make this as painless as possible. All right, continue on to the next video to start writing our first proofs.